Hello friends, this is part 2 of Solve Paper Elements of Modern Physics C-9 2023 4th semester Dibrugarh University. So in the last video we have solved MCQs, first question. So let's start from question number 2. So first one of question number 2, what is the photoelectric effect? Find the work function of a material. Okay, let's give you the answer. So here is the answer of question number 2a, right? This is the answer of question number 2a, definition of photoelectrons, right? Photoelectric effect. And what is work function of a material? Let me write here the definition of work function. The minimum amount of energy necessary to start the emission of electrons from the metal surface, is called work function. Of the metal, of that particular metal, right? Just wait. So hope you have understood this. Now let's move on to next question. The next question is, what are 3-level and 4-level lasers? Give examples of each type. Okay, let me give you answer. So this is the answer of question number 2b. Okay, this is what is about 3-level laser. Okay, so take the screenshot, this one and this one, and let me give you an example of 3-level laser. That is example of 3-level laser is ruby laser. Okay, that is Al2O3 crystals. Sorry. Now let's go to the 4-level laser here. 4-level laser. Okay, so just wait. Write this example after writing this part. Okay, so this should be written here. Just wait, let me cut it. Sorry. So after completing this portion, you should write the example of 3-level laser, that is ruby laser. Al2O3 crystal. Okay, and this is 4-level laser. Take the screenshot of this as well, and let me give you the example. Example of 4-level laser is this. Let me write it clearly. Okay, just wait. YAG laser. Okay, now let's move on to next question. So 2C, write down the semi-empirical mass formula and define binding energy. Okay, so let me give you the answer. So this is the semi-empirical mass formula. So all the details written about the formula here, and this is nuclear binding energy. This is in kg Hope you can recognize this. This is 2.98 into 10 to the power 8 meter per second. This is 1 joule, right? This is 1 MeV, 10 to the power 6 eV. These are conversions. Okay. Next question is, so that the phase velocity is half of the group velocity of non-relativistic particle. Okay, let me prove this one here. 2D. Okay, so when velocity v of a particle is massless than light, okay, and the velocity v of a particle much less than light, that is the non-relativistic case. Okay, this particle is said to be non-relativistic. Okay, so for this particle, EP is square by twice m, and momentum P is equal to m into v, and therefore this is the energy, right? And therefore the group velocity, phase velocity Vp is the phase velocity E by P. So if you simplify this, then what you're gonna have, P square by twice m, 1 by P, that's why you have to write 1 by m into V. So after simplification, what you're gonna have here, let me copy this and take a new slide. This one. So here is the conclusion. Here we have got this Vp is equal to V by 2, right? So for here you see this is nothing but phase velocity, and this is the particle velocity. Okay, so V is the particle velocity, and P is, this is momentum, M is the mass. So hope you know these things and mention these things in this proof. Okay, now next question is E. Describe how an electron and positron pair is created by gamma proton in the vicinity of nucleus. Let me give you the answers. Describe how an electron-positron pair is created by gamma photons. Okay, so here is the answer of 2E. Okay, now question number 3A. Explain the validity of Heisenberg's uncertainty principle using the gamma ray microscope throughout experiment. So this was done in paper, same question paper, but 2022 in 2022 paper of C9, in question number 6A we have got this same question, but that question was given as a short note citing. Okay, check that question number 6A of 2022 paper C9, right? So now let's move on to this question number 3B. Its answer is this one. So let me show you here. This is 3B answer. Take the screenshot. This one is the last slide of that answer. Okay, now let's move on to the next question. So this one 3C. So let me show you the answer here. The two cyclic processes involved in the thermonuclear fusion in deriving stellar energy. So here you see, so this is the answer 3C. Okay, so first cyclic process is this one, carbon nitrogen cycle. So just before writing the processes, just write this way one sentence: the two cyclic processes involved in the nuclear thermonuclear fusion deriving the stellar energy are carbon nitrogen cycle, take the screenshot, and proton cycle, take the screenshot. So answer is completed here. So let's move on to question number 4. So what is the wave function? So let me define the wave function, and how can the stationary states of a particle be explained using the concept of wave function. So here is the answer. This is the definition of wave function, and that's how we can explain the stationary states of a particle using the wave function, right? So take the screenshot. This is the wave function definition, and here the rest part of the question. So now let's move on to the next question. Question number 4B. Obtain the energy eigenvalues and the eigenfunctions of a particle in a one-dimensional rigid box. So let me show that one here. So this is the answer 4B. Okay, in 4B there are two questions. Either you have to solve this one or another question is there. So this is the next slide. Take the screenshot. First slide, second slide. Here is the third slide, and here is the last slide. I think no, this is not the last slide. One more slide is there. Take the screenshot, and this is the last slide. Let me show you again. So this is first, second, third, fourth, fifth. Okay, so now let's go back to the question paper. So here is the another part. Do you have the time dependence Schrodinger equation for the non-relativistic particle? So let me give you the answer. So this is the answer of this 4B or. Okay, so take the screenshot of this slide, then this slide, and last one, this one. Okay, all right. So now let's move on to question number 5. Okay, so here you see, just wait, this is question number 5. So do you have an expression for the Planck's law of radiation? So here is the answer. Take the screenshot. Okay, so let's move on to the next question. Explain the quantum mechanical tunneling for particle across a state potential. Obtain the expression for transmission coefficient. So this question was asked in 22 paper as well. Same question number in 22 also, in 2022 question number 5B. So this question was done. Okay, so check that video. Okay, so if you have solved the 2022 paper, so you have already written this one. So obtain the expression for the law of radioactive decay, and so that half-life of a radioactive substance is inversely proportional to the decay constant. Okay, let me give you the answer of this question as well. So before I give you the answer of this question, let me tell you one more thing. If you want me to continue my journey, please help me to get question papers from your juniors, seniors. Okay, so this is my Gmail ID, Oza Lekazid 123@gmail.com. Here you can send me question papers. Let me know where should I write. Just wait. Give me a moment here. So here is the Gmail ID, ozalukazit123@gmail.com. Please collect question papers and send me. Okay, then I can continue my journey and I can help you. Right. So now let's get back to the topic. Okay. So here you see, question number C, 5C answer. This is the 5C. Okay, so this is the expression, required expression, okay, for law of radioactive decay. And here you see, from this expression, this implies that this half-life period is inversely proportional to this decay constant, right? So hope you have understood this. So take the screenshot of this slide and this one, okay? And I'm really getting tired today, so this question number 6, solution of this answer to this question number 6 will be given in the next video. Thank you for watching. See you in the next video. Okay, stay connected. Please do subscribe to the channel, help me to grow my channel. Thank you.